And if I hit that one again, I can actually see the chat. And, whoa, we don't need that one there. We need that one there. Okay. All right, let's kick off so that we can get through this at a reasonable pace. So this morning is introduction to computer hardware. So in today's video, we'll look at the elements of what goes into building the actual personal computer. And again, just a reminder, this is a cluster of units, and we're using the Netacad resources for the theory. So after today, you would break off in the classroom and actually go build a computer. Now, as I said, we will redo all of these practical exercises, especially for the ones that need it. Still waiting on an answer from management as to whether we can lend out or sign out these things to you. So I'm told there should be computers there for assembly and disassembly, and in theory we should be able to sign them out to students, but they haven't confirmed that with us at the moment. So we'll look at general safety with electronics, look at the power supply, motherboard, internal drives, adapter cards that can be used, different storage media, and how to connect the basic components together with the cabling. So the first section is assembly. There is an explanation video in the chapter online which talks about removing your jewelry, anything that can conduct electricity. Basically, any types of metal you should remove. Make sure everything's turned off and unplugged. Even when it's unplugged, the power supply has some fairly decent capacitors in it, so it will store a charge even after it's unplugged from the wall. So it can still give you a jolt, but hopefully not as bad as if it was still plugged in. The cases are a hot cut metal, so they do have very sharp edges inside them, so you may want to cover those edges. Safety goggles. I've never worn safety goggles when doing a PC. That's an interesting new one. Okay, just cover proper lifting procedures, bend your knees, not your back, that sort of thing. Fire extinguishers are around. If you've unplugged everything, chances are you won't start a fire. Okay, fires start when it's still connected to the power. Okay, so cases and fans. Now, the basic case is built around a generic model of motherboard. So you need to buy your case to suit the type of motherboard that you're going to use. So the things that affect that is the size and shape. Now, when we look at the motherboards, we can get various expansion slots in them, which will increase the size, and the types of power adapters and that are on them also kind of change where the mounting points for the motherboard are. So all of that's got to be aligned with the case and the motherboard. Now, you need to ensure that you have enough room for air flow through the case. The power supply needs to match the power requirements of the completed system. So each component will have a power consumption rate. You've got to make sure you have enough power available through your power supply. Appearance is up to you. So is the basic form factor of a tower, flat desktop, mini, whatever method you wish to use. The type of displays or monitors you want to use, we'll talk about those in a little bit. And vents are basically there for fans to draw air through. Okay, so the main thing here is on a case you'll have various case fans which are about 4 inches wide, so 100 mil, and some cases will actually have smaller fans as well. Now the idea is to get airflow through the case to dissipate heat out of the case and keep your components at a relatively cool temperature. Your power supplies need to be fitted into the case. Now, a lot of cases when you order them will not have a power supply in them. So just be careful when you're ordering cases if you expect a power supply to be within the case, just double check, because most cases do not actually come supplied with a power supply. You need to buy them separately. Gold or platinum rated power supplies, they talk about the quality of the components that are used to build the power supply. Obviously, the higher the quality, the more clean the energy is that it supplies. Okay, and as a minimum, they basically start from around 300 watts. With gaming rigs these days, with the especially if you're looking at 2 video cards for gaming, that sort of experience, you should go for at least a 500 or if not 700 watt power supply just to provide the raw power. So the video on power supplies is basically how to align it and put in the screws. Now, I normally go through the exercise of teaching people that have never done a screw mechanical work before about how to avoid cross-threading the screws. Remember, anti-clockwise loosens stuff and clockwise tightens them. And if you align your screw in and just rotate it anti-clockwise until you feel a slight click, that's the start of the... Yes, Jacob, exactly. Righty-tighty, lefty-loosey. I was avoiding saying that one. So, rotate it to the left, you feel a slight click, which is the thread dropping into place, and then start going to the clockwise direction to tighten it up. And that generally avoids the cross-threading that may occur. So screws in that should be loose and easy to turn. when you're doing them up. So if you're finding pressure, chances are you're starting to cross thread. So just be aware of that one. Now, the motherboard is where everything basically plugs into. It's the control board. So the brains of the system, the CPU, the memory, or in today's environment, your video adapters, external video adapters can be plugged in. On most motherboards now, there is an inbuilt video system and audio system built into the motherboards again. If you've been around for as long as I have, you've seen it go from everything being on the motherboard to everything being separated into adapter cards, and now they've come back to being inbuilt into the motherboards again. Interesting life cycle. CPUs need some form of heat dissipation, which can be a heatsink and fan or water cooling. We'll look at those in a little while. The number and types of expansion slots will depend on the form factor of the motherboard you've selected, as well as the power connectors. So basically on this motherboard, this slot here is where the CPU goes in. You can see massive heat sinks covering chipsets that are on the motherboard. These black and blue slots here are where the memory goes. That one there, that darker blue one, is the main video adapter slot. And then we've got the ISO slots here. And what you'll have along here is the back of case connected ports. So your USB, your video, keyboard, mouse, audio jacks. This is your main power supply. And along here you'll have various connectors for case fans and things like that the power comes from the motherboard. And along here you'll have your connection points for your hard drives and so forth, your SATA adapters, and we'll look at those a little bit further. Again, how to mount it is a video explanation online for it. Selection, there's two main types of CPUs that we look at when we're talking about personal computers, and they are Intel and AMD. So Intel use an LGA adapter, which is basically no pin. It's just basically points of copper on the board, and they use pressure to actually press the two surfaces together. PGA use pins still, and they're about 3-4 mil long, and if you're not careful, they do quite easily pierce the skin.
They bend very easily.
The older boards were not zero force insertion. You actually had to put a lot of pressure in to lodge this type of system in, and when you needed to change your CPUs, if you weren't paying attention, you could slip and embed the CPU into yourself. And yes, I've had a CPU that has blood residue on pins. Yeah. I still occasionally can see the holes left in my finger from that experience. But yeah, you can, but you've got to be careful with straightening the pins on the CPUs, because you can break them and then it becomes unusable. Okay. Well, it was the old CPU that I was removing, so not really an issue, because it was being thrown out as afterwards. But basically, just give a clean with alcohol, isopol, and they're good to go again. But yeah, that one, ouch, that was a learning experience. Today's CPUs are zero force. In other words, you don't have to actually use force, they just sit in place, and then you put a lever down to lock them in place. Cooling. So here we have various different types. So the traditional one was a heatsink directly over the top of the CPU and with a direct fan to push air across the fins of the heatsink. Now, as the CPUs have increased in power, the heat generation has also increased. So we use different types of methods to get rid of that heat now. So we've got larger tower heat sinks that have copper tubing to vent the heat up through the fins, and fans to draw air through the cooling fins to dissipate the heat. Now you can have a single, dual, or you can have radiated liquid cooling, just like in a vehicle. So you have liquid circulating through the tubes and across a plate that sits on top of the CPU, and then you have fans driving air through a radiator to cool down the liquid, just like a car. And again, orientation of the CPU, if we step back, I didn't include it in these photos, but generally on a CPU in like this corner here, you'll notice the shape is consistent across the corners, but one of them will have that center pin missing, which indicates which corner has pin 1, and it generally on the other side here will have a mark, which is this corner up here, a little triangle saying this corner is pin 1, and you line those two marks up together when you're inserting them. Next is our RAM. Now, depending on the BIOS in use, we will select the RAM chipsets depending on the vendor's approved list. And basically this tells you the type of memory that can be used and supported speeds. So what does that mean? Depending on the RAM type, the way the memory is accessed and how fast it can be accessed, in other words, how fast can each bit of information in that type of memory be changed. It has to be stable and applied, and so that's got to do with the speed of the RAM chip. So how fast you can make changes and keep it stable has to do with the speed of the chip. Now, unbuffered or buffered memory just means that there are a section of memory that is stores information that is regularly accessed and assists in speeding up processes. So basically you would only find buffered memory in servers, generally speaking. This is different to the buffers that you'll find on motherboards and CPUs and things like that. So the insertion of the memory chips is very simple and easy. This is a little slot. Depending on the type of RAM, you'll have one slot or two slots. In today's ones, the DDR3s, there only is one. They're off-centered, and no two memory types are the same form, so you can't insert a DDR2 memory into a DDR3 slot and vice versa. So basically they just push down into the slot. The little tabs at the end of the slot lift up and click into place, locking in against these little tabs here, and you're making a connection along these circuit points along the bottom bridge. Hard drives. Now, these have various form factors. We started off with 3.5 inch. Now we've got 2.5 inch and 1.8 inch, they call it, I think, for memory. Basically, the portable hard drives or laptop hard drives are smaller, and then the ones that come into a desktop type environment are generally the 3.5 inch drives. So you've got internal, external hard drives, and you've got moving parts hard drives, which is your traditional hard disk, which has, if you remember the old record players, they actually have platters, and basically how they work is they spin, and a head just reads the magnetic field information coming back and forth along there. That's a platter out of an old hard drive that well, wasn't being used anymore because its capacity was so low. It was megabytes when we use gigabytes now. So they make nice coasters for us nerds. So now with the older drives, because they actually have a motor and a moving head and the discs actually spin, they generate noise and require more power. Excuse me. So the newer generation, the solid state hard drives, are basically just like our flash drives. They use no moving parts. They're all a straight electronic movement, so that there's no movement of parts, so no noise. They do generate a different heat signature, and they will require a slightly different power consumption from traditionals. How do you mount them? Well, you align the screw holes that are on the outside of the case of the hard drive with the mounting points within the case. So each of these bays, drive bays inside the case, will have mounting holes, and you basically push your hard drive through the slots, line up the screw holes, and then put your screw in and tighten. Now the top bays here are the 5 1/4 inch bays, which is now used for your optical drives. Back in the dim dark ages of IT, we used to have these things called floppy drives, and we used to have them in 2 sizes of 5 1/4 inch and 3 1/2. Now we basically just use them for our CDs and DVDs and Blu-ray drives. So, video demonstration of how to do that. So, yeah, optical drives are now dependent on the type of disk you want to use and whether you want it to be rewritable. So most of the disks can be backward compatible. So if you buy a Blu-ray disc, it will read an old CD or a DVD. Okay, and most of them will actually be able to write to that format as well. Occasionally there's compatibility issues, but generally speaking, all the vendors have made everything backward compatible now. So when you select, you've just got to make a choice whether you're going to have it only as a readable player or to be able to write. Now, rewrite, it's interesting that they have a separate column here. Basically, rewrite means you can reopen the disk and add to it. Okay, it doesn't write over the top of what's there. It just means you can add to it and not close it off. So how to install them? Well, the optical drives have to be inserted backwards in through the front of the case because their fascia plate actually sits in the front of the case, whereas your internal hard drives and that are inserted from internally in the case towards the front of the case. So these are your drive bays. So you insert it in, and again line up the mounting holes, put your screws in, tighten them up, and then add your cable connectors at the back. And there's a video on how to do that. So our adapter cards are used to add different abilities to our motherboard. So we can get graphic cards, sound cards, storage cards, memory cards, network adapters, all sorts of different cards to do different things. And within that, we have different slots that have different characteristics on how they communicate. So basically, it's got to do with the speed of the slot. So we have our peripheral component interconnect PCI, and then we have our express slots. So basically, we come up with our original one. PCIs are actually this one. Okay. I love how they've circled the wrong ones. The X16 is actually the correct one there. So your larger ones were your PCIs, and then you've got an 8 and a 4, which are these smaller ones. and the X16s are normally the ones used for your graphics cards because they need the faster speed. So your form factor of case and motherboard will also play into what adapter cards can be supplied. So sound cards, video graphic cards, I/O ports. So you got to, if you need more USB ports, network cards, capture cards are dedicated video or audio capture cards. So they're high-end versions of a sound card or a graphics card that are specific to a function. How do you mount them? Well, the case will have expansion slots which line up with the various slots. Now, they will be offset, so your card plugs into there, and then all the adapters are offset off the card. So you'll put the card in this slot and it'll line up with that. That slot will line up into that one. You press we would normally refer to it as a daughter board, into the expansion slot and then secure it from movement with a screw along the edge of the case. And here's a video for you to watch. And no, I didn't include the videos into the presentation. I figured you can just do that at leisure on your own. In today's environment, we have lots of different devices out there like camcorders, memory sticks. My wife's actually got cross-stitching, sewing machines and all sorts of fancy stuff that actually have memory cards in them to do automated features. So they have different types of portable media. So our micro SD, compact flash, memory sticks, and we can put a multimedia reader into one of our expansion bays in the drive bays to have access to all those different types of media through easy access. External storage, our USB flash drives is the most common. The other one is portable hard drives that actually connect via the USB or SATA or Thunder ports if you're an Apple person. And there's also a new interesting high-speed, they call it a storage port, but it's basically just a flash drive that you mount on the motherboard. Now, on the front panels, you'll have all these lovely LED lights and switches to turn things on and off. So there are various front panel connectors that you need to put into the motherboard, and they align with specific pins on the motherboard. Now, the instruction manual for your motherboard has all of these clearly labelled, and generally you will have the some form of indicator on the actual motherboard itself as to which pins are for what. So this one, you have your hard drive light, which is this one here, HDD LED, so that one goes there. Reset switch, so you got your power switch there, reset there. So these 2 pins would be the reset. These 4 pins across the back is where your speaker sits, so it'll be using these 2 outer pins. This one's for your 2 pins for your power on off, and your power LED, which these 2 plus or minus. So this one, it's got a little plus there, minus there. So the minus LED goes on that pin there. Just take your time, make sure you've got a good light source, so you can read the writing on these boards clearly. So each one of them will have an indicator of which one is the positive, and it'll have a little mark on the pin. As I said, you just go through and align each one with the appropriate pins. Now, word of advice, do this before you mount adapter cards and things like that, because once you start putting adapter cards and all that sort of stuff in on the motherboard, you start losing space to be able to add these in. So give yourself maximum space. Do it before you put your cards and drives and that in. So mount your motherboard and then connect your front panel connectors and then your CPU connectors to the motherboard, and then add your drives and things like that. Again, USB ports at the front, they need a cable to be connected to your motherboard. Now these USBs will come in pairs, and generally speaking you'll have them all connected in one plug. So you've got your 2 separate USB port leads, but they use a single plug and just slot in. Now you'll notice there's a pin missing from one row, and it coincides with a blank on the actual plug, so it can only go in one way. Again, video to see it all happening, and the second video there is just making sure you get all of these things back together and turn it on to make sure it all works. Now, if we're in the classroom, this is where I would say, okay, the lab for today is, here's the hardware. We will get back and do all the practical labs regarding hardware assembly and that. I did say it will be next term at this stage, which is fine. This cluster runs until the end of term 3, so we've still got plenty of time to catch up on that practical side when we get back into the classroom. So today's tasks are to read the online chapters. Now, I noticed some of you have done chapter 1 exam. This week's task is to do the chapter 2 exam. For those that have not completed the chapter 1 exam, I have turned that one and chapter 2 on. Okay, don't let yourself get too far behind in doing the chapter tests, or else you just lose the time span between reading the material and taking the test, and your results will suffer because of that. Now, the actual first assignment for ICT 421 is able to be completed after today's chapter. Basically, it gets you to list all the components of a computer. So we've just gone through the components. So you've got your adapter cards, your RAM, your CPU types, So you get to list those. It also asks you to give a brief explanation for each component. And the third part of the question on assignment 1 is to list any technologies that have superseded other technologies within the components, which is just about all of them. Just yes, assignment is the one out of my learning. Now, I have put the assignment into Discord so that people can just quickly grab it, as it may be easier for people, as some people may still not be on the system. I haven't got notification that a couple of people's enrollment have not been finalised as of yet. So normally I get a notification when that's finalised. In the meantime, for those individuals, just grab it off of Discord and post it up into Edmodo. That's fine, or email it to me for marking. But those that have access to My Learning, just submit it via My Learning, and that gives me a notification and I can grade them all on that system. Okay. The assignment will be due next week. It should take you all of about an hour to do. It's basically just going through that presentation and writing out the component names again and doing a bit of research on what they are, and like for the RAMs, the current one is say DDR3, and there was DDR1 and 2, that sort of thing. So just say, yes, this is the current form of the component and it superseded these things. Why? Improvement in technology, speed, whatever. Just a brief explanation of what's changed will be appropriate there. So the task for this week is for you to go off and read chapter 2 of the online material, complete the first assignment for ICT 421, and complete the chapter exam within the Netacad environment. The chapter exams are turned on for the week. You can do them anytime during the next week, and they are enabled for, once you start the exam's for 2 hours. Now, most of them are about 19, 20 questions, so that's more than enough time for you to complete. Okay. I'll turn that off and turn that